Hello students, welcome back. Now we are going to discuss about regarding data types supported by Vhdl. Okay, data types supported by Vhdl. So actually in Vhdl, all the variables, signals and constants must be associated with a data types. Okay, in Vhdl, all the variables, signals and constants must be associated with these data types. Okay, so there are various data types are there that are supported by Vhdl. Okay, now we are going to discuss about regarding data types supported by Vhdl. So different data types that are declared as, first one, integer. Okay, integer is one of the data type. Second one is real. Third one is enumeration. Fourth one is physical. Fifth one is array. Sixth one is record. Seventh one is access. Eighth one is file. Okay, so all these are the different data types which are supported by Vhdl. Okay, now we discuss about these data types in detail. Okay, not all this. Okay, we discuss some of the data types. Now coming to the first one, that is integer. Okay, integer is, it is defined in the following range. Okay, integer, that is having numbers there, right? Integer, it is having numbers, right? So that can be in the range of minus 2 comma 147 comma 483 647 to 2 comma 147 483 647. So this one is the range of the integer. Okay, in Vhdl, right? So in this we can declare the numbers. Okay, that are regarding integers. Now coming to the example. Okay, so in this example we are taking it as, so here architecture MA. Okay, MA of X. Okay, that is here the architecture name, right? And then begin. After begin, right? So we are going to write the process of K, right? So now we have to take the variable V. For this we are giving it as integer. For the variable V we are giving it as integer, right? And then begin. So after begin we have to write the code here. Okay, so we are declaring the different numbers here, right? Like V less than or equal to 1, V less than or equal to minus 1, when V less than equal to 1.0. So we are giving the different numbers for this variable V. Okay, so already we have started a process here, right? That's why we have to end process, right? And then end architecture MA. So here the architecture name is MA here. Just we have taken it as MA. So that is the end MA. So this one is the example for this integer. So for the integer, actually we have, for the variable we have to declare the numbers. Okay, for that we are making it, we are mentioning it as integer. Okay, so this one is the range of this integer. Okay, that is regarding integer data type. Fine. Next, real. Next one is real. So it is also one of the data type, right? So this one is having the range of minus 1.0 E38 to positive plus 1.0 E38. Okay, this one is the range of the real. Fine. Now we'll see the example for this real. Okay, architecture AZ of LV. So here the architecture name is AZ here. Fine. Next, begin. After begin, just we are taking the process of J. For the variable P we are mentioning it as real. Okay, for the P variable we are mentioning it as real data type. So previously we mentioned it as integer. Now we are giving it as real here, right? So for this variable we are giving the different values here. After begin we have to write the code, that is of P less than equal to 1.3, P less than equal to minus 7.5, P less than equal to 1.7 E13, P less than equal to minus 2.3. 3. So it can take both negative and positive values, right? So like that we can give the different values for this variable p. Why? Because the range is having real minus 1.0838 to 1.0e38. So that is a range of this real data type. Fine. So that is regarding real data type. And now coming to the next data type, that one is enumeration. So in this type the user specifies the list of possible values. Okay, in this data type the user can specify the list of possible values. Fine. So here we can give the boolean values also, right? So take the example, right? Type binary is on or off. So that one is values for boolean. Okay, boolean values. Fine. Next, architecture test enum. Test enum is one of the name for this architecture of DT. Data type is process of M, variable B, right? So here we are giving the binary value. For this variable B, we are giving the binary value here. So binary means here on or off. We already given the values here, right? So that we write the code after begin. B less than or equal to on, B less than or equal to off. So in this way we can give the binary values for this variable B. So hence we have mentioned the variable B as binary here. Fine. Next, here we have opened process, right? So that end process, already architecture name has been started here. So that write it as end enum, end test enum. So that is the architecture name. So wherever we have started the architecture, that we have to end in last. Okay. So in this way we can take the example for this enumeration. So in this enumeration we can give the values. Okay, binary values like boolean values, find, on or off, right? Find or miss, like that. Found or miss, like that we can give the values, right? So that is regarding enumeration data type. Next one is physical. Next data type is physical. So in this physical data type, so it describes the objects in terms of base unit. It describes the objects in terms of base unit, multiples of base unit and a specified range. So the base unit that are having range, right? That is a particular specified range. Now we'll see the example by this, right? So first one, type name is range constraints. That is here the for the range constraints we have to mention the range, how much we are taking this, right? Next, units. So we are giving the base unit here, right? Again, end units. So in this way the syntax for this physical data type. Now we'll see the example for this. Okay, predefined physical type format. Okay, whatever it is, the example for this physical data type. Time is range from minus 2 into 31 to 2 into 31. So here we are taking the range here. Units, fs, femtoseconds, that is equal to 10 power minus 15 seconds. Picoseconds, that is equal to 1000 fs, that is a femtoseconds. Nanoseconds, that is a 1000 picoseconds. ms, that is equal to 1000 nanoseconds. In this way we can take the units here, right? Base units or multiple units also we can take, right? So here units shorted now, right? Units shorted, so that we have to end units, right? And every line that should be end with semicolon here. Every line that should be end with semicolon. Fine. So that is the example for this physical data type, right? Next, array. So already you know array means nothing but the group of the elements which are of same type. Array is the group of the elements of same type into a single Vhdl object. Okay, the array is one of the group of elements that are of same type. Okay, so the range should be constrained when array is used. Here when you are mentioning the array, the range should be constrained, right? That is from 0 to 100 or like that, right? So that we'll see the example for this. Okay, type data bus, okay, is array of, here we mentioned the range 0 to 31 of bit. So for this variable a, we are giving it as data bus. Okay. Next variable b is bit. So here the array is having from 0 to 31. So we are mentioning it as for bit. That is b less than equal to a of 12. So a is also in the range of 0 to 31. So that's why we are writing it as b less than equal to a of 12. So that should be ended with semicolon, right? So that is the example for this array. So while you are mentioning the array, the range should be specified over there. Okay, the range should be mentioned, right? So that is the example for this array. So that is regarding data types supported by Vhdl. Okay, so we are having different data types. Okay, for that one, first one, integer, enumeration, physical, record, array, access, file, enumeration. So all these are the data types. So in this one we discussed some of the data types which are supported by Vhdl. Okay, that is regarding data types. Okay, thank you all. Thank you.